Okay. Now this one should be a little bit shorter because the disassociation is the hard work, but doing net ionic equations is not so hard once you've got this part down. So let's go ahead and bring this up. I'm gonna do just one example. I'll talk about it a tiny little bit here. So basically, when you put this is a double replacement reaction, basically, and what you want to do is just be able to write the important part. There's ions in here that don't really do anything. They're called spectator ions, and so what we're going to do is delete those and just show the important part of the reaction. So when you put sodium sodium sulfate, barium chloride, and sodium chloride in water, they disassociate. Well, the reason the reaction goes this direction is because when a barium and a sulfate come in contact, it becomes a solid and it drops out of the solution. The solution becomes like a milky color. So this one, you do not disassociate because of the solid. There we go. So let's go ahead and I'll do this one as an example. I think we got plenty of room here. Yeah, we're still recording. So I like blue. Let's go back. So because of the 2 here, we're going to write 2 in A. If you look up sodium, it's a +1. After doing a few of these, you tend to memorize these. Because of the +2, you automatically know that's a -2. And if you look it up on the table of polyatomic ions, you'll see that it's a -2. Barium is +2. Now we should be writing the aqueous down here, but because that ends up being time consuming, I'm only going to focus on the solid, writing the solid or liquid or gas. If it's not aqueous, we should be writing it because it's different. So this one, there's 2 chlorines because of that 2 right there. Remember to bring the coefficient in front because now there are 2 separate things wandering around in the solution. It has just a -1 charge. That still balances out because 2 times -1 is +2. Now I'm done with the left side. Let's write the right side. Remember, the solid you do not break up. Barium sulfate, solid. And definitely write the solid so that you can remember. Plus, and we break up 2Na plus 2 chlorine negative. Now you see this 2, when these split up, it applies to everything. So you got to spread the love of that 2 around right there. Okay, so now the fun part, get rid of the spectator ions. That's those 2. And these 2. Now to finish the job, you want to rewrite it with just the net ionic equation is what's left over. I always write the metal first. Barium is a metal, so I'm going to write Ba +2. Yes, it's still correct if you wrote it the different, with them switched, but metals are on the left side of the periodic table, so they're written usually on the left side of a chemical equation. That's aqueous yields BaSO4 solid. And that's my answer. I'm going to do another one from the list down below. I found 4 was a good example, so we're going to do 4. So first of all, is this equation balanced? This chemical reaction, is it balanced? You might want to pause the video and take a look at that. Okay, the first thing I notice is that there's 3 hydroxides here. So in order to fix that, I need to put a 3 here. But then that breaks this problem. This sodium over here there's only 1. So I'm going to put a 3 here, and now my sodium is balanced. But guess what? As a bonus, that gives me the 3 chlorines I need for this as well. So now it's balanced. Make sure you balance these before you go to dissociate. It makes it a lot cleaner. So now, because of the 3, I'm going to write it out like this. 3, let's go back to blue. 3 Na plus 3 hydroxide negative plus iron plus 3, and I know it's plus 3 because there was 3 chlorines here, and I know chlorines are -1, plus chlorine negative, but don't forget your 3, and that yields the solid. You just rewrite OH3, and please put the solid there because that's important, plus 3 sodium plus 3 chlorine negative. Now the spectator ions should be easy to identify. 3 chlorines right there. And then the sodiums are also spectator ions. So now go down and write the net ionic equation. I'm going to write the metal first. Fe plus 3 plus 3 hydroxides. That's on the polyatomic ion list. Yields Fe OH hydroxide, that is 3. That's an ugly 3. Let's try that again. 3 solid. And there it is. There's your net ionic equation. And hope that helps.